Hello everyone, welcome to my channel. You are learning with Dr. Shobha Nikam. In this video, I'll talk about shift register, types of shift registers, their applications and detailed working of each and every type of shift register. So shift register is basically a sequential logic circuit. It has flip-flops. Register is a circuit which is combination of flip-flops which can store data, only registers. Shift register means it can shift data. So that shifting of data can be in serial manner or it can be in parallel manner. So types of shift registers are serial in, serial out. It means data enters serially and comes out serially. Serial in, parallel out. Data enters serially but comes out parallelly. Parallel in, serial out. Data enters serially and it comes out one after another. Parallel in, parallel out, enters parallelly and comes out parallelly. Applications of shift register are to store data, so data storage. Data transfer, it means we can shift data from left to right or right to left. So data transfer. Then to perform arithmetic operations like multiplication and division. So let's see how to perform multiplication and division. So if my data is 0001 and if I'll perform left shift operation, 0001 means what? 1. If I'll shift data towards left, then this 0 will come here, this 0 will come here, this 1 will come here and this is 0. Now this becomes 2. Again if I'll shift, this 0 will come here, this 1 will come here, this 0 will come here and here is 0. So it becomes 4. Binary equivalent, the decimal equivalent is 4. So this is nothing but multiplication by 2. 1, then 2, then 4, then this will become 8. So this is multiplication by 2. So in this way we can perform multiplication operation. By shifting data towards right or right shift, we can perform division operation. So see 1,000,000, suppose my data is. So this is what? 8. If I shift data in this way, then this 1 will come here, this 0 will come here, this 0 will come here. Now this becomes 4. Again if I'll shift, this 1 will come here, so this becomes 2. Then 001. So this is 1. So this is division operation, division by 2. So by using shift registers, we can perform multiplication and division operation also. Then now we know there are 4 types of shift registers: serial in, serial out, serial in, parallel out, PISO, PIPO. We need to know how many clock cycles are required to load data into that shift register, then how many clock cycles are needed to read data, and total number of clock cycles. So this table is very important. You should know this table. So in, serial out, number of clock cycles to load data are n. N means number of bits. If my shift register is 4-bit shift register, then it will take 4 clock cycles. I'll verify this table when I'll explain each and every type in details. Now you won't understand why it is n, why it is n minus 1, but while explaining every shift register in details, you'll understand this. So this table is also very important. So let's start with first type, that is serial in, serial out. So I'll take example of 4-bit serial in, serial out shift register. So simple block diagram is this. It has serial data input. So this is D in. Data comes out serially. So this is D out. This is SISO. And this is sequential circuit. It has D flip-flops. We use D flip-flops in shift registers. So one more input is clock input. So this is SISO shift register. For 4-bit shift register, we need 4 D flip-flops. So these are my 4 flip-flops. This is data input, this is Q output. So I'll mark least significant bit here. This is Q0, D0, Q1, D1, Q2, D2, Q3, D3. Then this is my clock input. All shift registers are synchronous circuits. So I'll connect all clocks together. So all clocks are connected together. I'll enter data from this side. So let's assume my data is 4 times 1, and this is serial in, serial out mode. It means to perform right shift operation, I'll connect output of this leftmost flip-flop to input of next flip-flop. Q3 is connected to D2, Q2 is connected to D1, Q1 to D0. For left shift operation, what I'll do, I'll connect Q0 to D1, Q1 to D2, Q2 to D3. So these are my 4 outputs, Q0, Q1, Q2, Q3. Initially all these outputs are 0. After first clock pulse, this is my first clock pulse. Sorry, this is actually a falling edge triggered flip-flop. So I'll show it in this way. So during my first clock edge, this 1 will come here. First bit will come here. So this will become 1, 0, 0, 0. After second clock pulse, this 1 will come here and the external 1 will come here. So 1, this 0 will come here, this 0 will come here. Now output is 1, 1, 0, 0. After next clock pulse, this 1 will come here, this 1 will come here, this 0 will come here, and this third 1 will come inside the shift register. 4th clock cycle, this 4th one will come here at Q3 and this data will shift towards right. 1, 1, this one will come here and this one will come here. So see here, number of clock cycles are 4. 1, 2, 3, 4. To load data into this shift register, to load entire data into this shift register, it took 4 clock cycles because my shift register is 4-bit shift register. So for n-bit shift register, it will take n clock cycles. Now see, to read data, to load n cycles. To read data, this Q0 is already in. This is our serial output. Output where we will check? We'll check our output here only. This is our output. These 3 are not externally available. So how many bits are available now? 1 bit is available. Then after one more clock cycle, this second bit will be available. After one more clock cycle, this third bit will be available. Then again one more clock cycle, this 4th bit will be available. So how many clock cycles are needed? This one is already available and now we need 3 more clock cycles. So 3 is what? 4 minus 1, because our flip-flops are 4. So here, to read data, for reading we need n minus 1 cycles. Why n minus 1? Because 1 bit is already available during loading. So to read, we need extra n minus 1 cycles. So here, as explained in first table, in serial out shift register, for loading n clock cycles are required. For reading n minus 1 clock cycles are required, and total n plus n minus 1 to n minus 1 clock cycles are needed. Now let's discuss about serial in parallel out. So next mode is serial in parallel out. Data enters serially, so there is only one data input and data comes out parallelly. So we have 4 outputs, Q0, Q1, Q2 and Q3, because this is our 4-bit shift register, and one more input is clock input. Now let's draw a diagram using flip-flops. Just like serial in, serial out, I have taken 4 flip-flops. Q0, D0, Q1, D1, Q2, D2, Q3, D3. This is synchronous circuit. So a single external clock is connected to all flip-flops. Data enters serially. So this is here, my external data will come. So again, I'll take same example, 4 ones. So this is my D in and enters serially. So I'll connect output of first flip-flop to input of second, output of second to third, in this way. And here output is parallel mode output. So I'll get all 4 outputs simultaneously. So this is my Q0. Here I'll get Q1. Here I'll get Q2. And here I'll get Q3. So Q0, Q1, Q2, Q3. Now let's see how it works. Initially all 4 outputs are 0. Then we'll start loading these 4 bits. So for first clock cycle, this is our negative edge triggered. This bubble indicates negative edge. So this first one will come inside. So 1 will come here. In D flip-flop, whichever data is present at the input side comes at the output side. This is simple functionality of D flip-flops. So this 1 will come here. This 0 will come here. This 0 will come here. And this 0 will come here. See, Q3 is acting as input to second flip-flop. So whichever data is present at Q3 will act as data input to second flip-flop, and the same will come to Q2 after 1 clock cycle. Similarly, Q2 is connected to D1. So after 1 clock cycle, data present at D1 will come to Q1. Similarly, after 1 more clock cycle, this second bit will come inside. And this one will come here. So 1, 1, 0, 0. After 1 more clock cycle, the third bit will come. So 1, and this one will come here. This one will come here. And this 0 will come here. After 4th clock cycle, the 4th bit will come inside. And these 3 ones will come here. 1, 1, 1. So after 4 clock cycles, I am able to load entire data into my flip-flop. So for loading, I need n clock cycles, serial in, parallel out. I need n clock cycles. And for reading, I need 0 clock cycles, because see here, now outputs are all 4 outputs, Q0, Q1, Q2, Q3. Now you can see, you can read your output here. Your output is, already you got the output, Q0 is 1, Q1 is 1, Q2 is 1, Q3 is 1. So no extra clock cycle is needed to read the data. Now let's talk about parallel in, parallel out. So see here, data enters parallelly. So 4 separate inputs are available, 4 separate outputs are available, and 1 clock input is available. Now let's draw the diagram using flip-flops. Here I have taken 4 flip-flops and data enters parallelly. So all 4 inputs are externally available, and data comes out parallelly. So all 4 outputs are also externally available. There is no connection between 2 flip-flops, but they work in synchronization because single external clock drives all 4 flip-flops. So all 4 flip-flops will load data simultaneously and they'll give output simultaneously. So initially all 4 outputs are 0. After 1 clock cycles, all 4 data inputs will get loaded into flip-flops. So here, if again data is 1, 1, 1 and 1. So here 1, 1, 1 will get loaded, and in D flip-flop whichever input is present will get at the output. So see here, only 1 clock cycle is needed to load the data. So in parallel out, 1 clock cycle is needed to load the data, and output is already available. We don't need any extra clock cycle to read. So for reading, number of clock cycles are 0, total clock cycles are 1. Now let's talk about parallel in, serial out. So this is parallel in, serial out shift register. This works in very simple way. Just because of this diagram, few students feel this is complicated, but this is not at all complicated. You just need to concentrate. In parallel in, serial out, we have 4 parallel inputs, D0, D1, D2, D3. We have output, serial output. So only 1 out, parallel in, serial out. And this is a clock. To draw this diagram using flip-flops, I have taken 4 flip-flops. Just like other shift registers, Their clock terminal is shorted, single external clock is connected. Now here, this is my Q0, D0, Q1, D1, Q2, D2, Q3, D3. So these are my 4 flip-flops. Now let's see. See here, we are loading data parallelly, and also we are shifting data from one flip-flop to another, second to third, either in from left to right or right to left. So it works in 2 modes. First is shift mode or load mode. Shift mode is on, then data will shift. If load mode is on, then data will get loaded. So let's start with load mode. So here what is given? Load bar. Load bar means if this is 0, if this input is 0, then I can load the data. Now see what will happen. If this is 0, output of this NOT gate is 1. So here input is 0, here input is 0, and here input is 0. So that this AND gate will generate output 0. This AND gate will also generate output 0, and this AND gate will also generate output 0. And here this is 1. So 1 input to these 3 AND gates is 1. So whichever data is present here at D2, D1 and D0 will come here. So again I'll take same example. My data is 1, 1, 1 and 1. So what I'll get here? I'll get 1 here, 1 here, 1 here and 1 here. So because the other input is also 1, output of this AND gate is 1. So 0 plus 1, here we'll get 1. Here also we'll get 1, and here also we will get 1. So you can see I can load data into these 4 flip-flops in one clock cycle. So only one clock cycle is needed. What I need to do? I need to make this input 0, and in one clock cycle all data will get fetched into my shift register. So in parallel in serial out shift register, number of clock cycles needed to load data is 1. Now let's see shift operation. For shift operation, this input needs to be 1. For shifting, this will become 1. This input will become 1. So when this input is 1, output of this NOT gate is now 0. So here input to second AND gate is 0. Here it is 0 and here it is 0. It means these AND gates will not generate any output during shift mode. So these are off during shift mode. So this AND gate, input to this AND gate is 1, because this is 1 now for shift mode. So this input is 1, this input is 1 and this input is 1, and other input is to this AND gate is Q3. So if Q3 is 1, this AND gate will generate output 1 and this 1 will come here. So Q3 will come to D2 through this AND gate and this OR gate. Similarly, Q2 will come to D1 through this AND gate and OR gate. Similarly, Q1 will also come here through these 2 gates. In this way, during shift mode, data will get shifted from one flip-flop to other flip-flop. Now let's see how many clock cycles are needed to read the data. Initially all 4 outputs are 0. After one clock cycle, entire data will get loaded. So here what will get? All 4 ones. So this is for loading. Now what output is available? Where we will check our output? We will check our output at Q0 only. We will not check Q1, Q2 and Q3 because this is not parallel output. This is my serial output. So I will check only Q1. 0. So now what I am getting? 1. I need these 3 ones to come here, so that after 1 clock cycle, this 1 will come here, this 1 will come here, and this 1 will come here, and here it becomes 0. After 1 more clock cycles, 0, 0, 1, 1. After 1 more clock cycle, 0, 0, 0, 1. Now here you can see, now I got all 4 bits. My first bit LSB, this is my MSB. So how many clock cycles are needed now? To read, we need 3 clock cycles for reading. Number of bits are 4. So how many clock cycles are needed here? 4 minus 1, that is 3. So n minus 1 clock cycles are needed for reading the data. So this is all about shift registers. I hope this video is useful to you all. If you find this video useful, share it with your friends. Press the like button. Don't forget to press like button. Comment on it and subscribe to my channel. Thank you so much for watching.